This video will help you and hopefully remind you about some basics of trigonometry. We're going to talk about sine, cosine, and tangent, and then the inverse trig functions, inverse sine, inverse cosine, and inverse tangent. I hope that you've seen this stuff before in a formal trig class. If not, you're probably going to need a lot more than just this video. But if you've seen it before and you just need a refresher, this video should probably be sufficient. But if not, you should probably go online and search out some more formal help or go to the UNF tutoring center and get some specific math help on learning a few basic things in trig. So you may remember the phrase so, ka, toa. It's a mnemonic device to remember the relationships that define the function sine, cosine, and tangent. All of these, the O, A, and H refer to the sides of a right triangle. So O is the opposite side, A is the adjacent, and H is the hypotenuse. And all of these sides are in reference to a particular angle. So in this particular picture, I've labeled this angle down here as the angle theta. So this side is adjacent to theta. That side is opposite to theta. The hypotenuse is always opposite to the 90-degree angle in the right triangle. So always make sure that you identify what angle you're talking about and then label the sides adjacent, opposite, and hypotenuse based on that angle. So the sine function intakes an angle, and the sine of that angle is equal to the ratio of the opposite side length to the hypotenuse length. So the O and the H are the lengths of the opposite side or the hypotenuse. And so this is a relationship, this is an equation that you can use to solve for an unknown if you do know one angle on one side of the triangle. So that's the sine function, that's the so of SOHCAHTOA. Ka shows you that the cosine of an angle is the adjacent side divided by the hypotenuse. And then toa, tangent of theta, is the opposite side over the adjacent side. So if you know any angle and any one side in a right triangle, you can use these functions to solve for the other sides of the triangle. Let's give it a try in this example right here. I have a triangle. I know the hypotenuse. So H is 10 in this particular triangle. I have an angle. Based on that angle right now, I'm going to label the sides. So this side down here would be the opposite side. It's opposite from that angle that I'm talking about. And this one on the right here is the adjacent side. So let's use the sine, cosine, or tangent functions to solve for both of these sides. Let's take the opposite side first. I know the hypotenuse, I know an angle, I need the opposite. So opposite's what I'm looking for, hypotenuse is what I know, and an angle is what I know. So I think the sine function would be the most useful here. So the sine of theta is equal to the opposite over the hypotenuse. Let's solve this equation algebraically first before we plug in numbers. So I'm going to multiply both sides by the hypotenuse. That'll cancel the hypotenuse in the denominator with this hypotenuse in a numerator. And so I get that the opposite side is the hypotenuse times the sine of theta. So now let's plug in some numbers. 10 times the sine of 53. Notice that my angle here is in units of degrees, and so my calculator should also be in units of degrees. So I'm going to do 10 times the sine of 53, and I get 7.99. So that's the length of the opposite side. Let's solve for the adjacent. In this case, I know the hypotenuse and the opposite, so I could use any trig function here I wanted. I'm going to go ahead and just use cosine. So cosine of theta is the adjacent divided by the hypotenuse. Again, I need to solve my equation algebraically. So I'm going to multiply both sides by the hypotenuse. And I get that the adjacent is the hypotenuse times the cosine of theta. That's 10 times the cosine of 53. And I get 6.02. So those are the two sides of the right triangle that I was given. The other functions that you need to know are called the inverse trig functions. These functions are used when you don't know the angle. You do know the sides, but you need the angle. So these trig functions, they're just solved versions of the basic trig function. So if you start over here with the basic trig functions, if you just solve, take the inverse of both sides, you can get the angle all by itself. So these are the inverse trig functions: inverse sine, inverse cosine, inverse tangent. These are the functions you should use if you don't know an angle, if you're trying to solve for an angle. You'll notice here that SOHCAHTOA still makes sense. That the inverse sine still uses opposite and hypotenuse, inverse cosine still uses adjacent and hypotenuse, and inverse tangent uses opposite and adjacent. Let's do one more problem together, kind of putting all of this together. The problem says, determine the smallest angle that this arrow makes with a horizontal line placed at its tail. So let's draw a horizontal line. The smallest angle. So this is the angle right here. This is what I'm looking for. I'm going to call this angle alpha. That's what I'm being asked to figure out. Based on this picture here, I can see that the arrow forms the hypotenuse of a right triangle, where the horizontal leg of the triangle is 15.5 meters and the vertical leg of that triangle is 6 meters. Now, if I want to find that angle alpha, I notice here that this angle, we can label this one theta. Alpha plus theta is equal to 90 degrees. Those two are complementary angles. So if I can solve for theta, then I can just subtract it from 90 degrees and that'll give me the angle alpha that I'm looking for. So alpha is just going to be 90 degrees minus theta. So let's do some trig and solve for theta. So I'm going to redraw this triangle just so we can see it a little bit better. Based on the angle that's labeled here, I would say that that vertical side, that is my adjacent side. And the horizontal side, that would be my opposite. Okay, so I need the angle. I know the opposite and the adjacent. If you go back to our inverse trig functions, I have the opposite, I have the adjacent, I need an angle. I think the inverse tangent function is what will be very useful here. So theta is equal to the inverse tangent of the opposite over the adjacent. So that's the inverse tangent of 15.5 meters divided by 6 meters. You plug that into your calculator. I get 68.8 degrees. My calculator is still in degree mode, and that's why I know that that number that came out is in units of degrees. So if I know theta is 68.8, that means that the angle that I'm really looking for, alpha, is 90 minus 68.8. So this angle alpha, that's the smallest angle that my arrow is making with that horizontal line drawn on its tail, is 21.2 degrees. And that is my final answer.